But what we're here to present today is Moneyball, how data and AI have revolutionized the data analytics game in sports. And some of you might have already watched the blockbuster movie starring Brad Pitt about the success of a real life story where they used statistics and data analysis to really gain the edge over teams who had much higher budgets, much better players. What they were able to do, Billy Bean and a guy called Ari Kaplan, what they did, they got together, looked at the data and thought, we can make something of this. We can really gain the edge there. And this has had such an impact on how people view analytics in sports. Baseball is always one of those sports where people are always so keen to focus on the stats. And I've really seen examples across all sports where you can see that data has really had that impact. So what we're going to do today, unfortunately, I'm not a baseball fan. We are in the UK. It's not as big a sport here compared to some other sports that we have. I've presented this session 3 or 4 times and once in the US, so obviously I had to talk about baseball. But every single time I've presented this session in the UK or in Europe, I have maybe one hand in the audience that goes up when I ask who are the baseball fans in this room. If I was to ask Tony here if he was a baseball fan, he would probably say no. Exactly. So we're going to pander to the audience. We're going to go for a session that teaches us best, because this isn't a session about sports. I'm not going to talk to you for the next hour about how much I love sports. I'm going to talk to you about my love for data and how I'm seeing that represented so well in the world of sports. So you can see here that what we have on screen right now is a bicycle kick from the legendary Brazilian footballer Pelé. And you can see that this was in 1968. Things were still in black and white, but what you can look at this photo and infer is the fact that this man is showing great athletic ability to almost do a backflip, kick the ball, and subsequently score a goal off the back of this. You'll now see a second picture on screen, which is Cristiano Ronaldo attempting the same kick, which did result in a goal as well. And you can see here straight away that these photos are pretty much 50 years apart. And I can tell you that there's one key fundamental difference between these two kicks. And it's not the fact that one's in black and white and one's in color. The difference between these two photos is the fact that with Cristiano Ronaldo's kick, we have a lot more data, a lot more visualization and analysis on how he's able to achieve something like this. Now, the figures on screen might not be 100% accurate, but sensors in the footballs, cameras on the pitch tracking players' movement in real time, we are able to gather data like this to see how much of an extent the players are able to really deliver on the pitch. And you can see here that most normal human beings without a lot of training and dedication maybe couldn't jump almost 1.41 meters into the air, do a backflip, and kick and score the goal. And for those of you that might not have seen it, this is the goal in 2018 in the Champions League against Juventus, and you can see that the Juventus team has no idea what to do. They're stunned. We'll play it again. And you can see here that in a split second, Ronaldo's made that decision to go for that sort of goal. And he's delivered. He's managed to score that goal. And you can see here, this is a different angle. And to be able to precisely score that goal, to reach the football in that way and make the ball go into the net, that does take a certain amount of talent. Although not all footballers are this talented. And speaking of people who don't have enough talent to maybe pull off a kick like this, my name is Jayanty. I'm a data engineer based in Edinburgh in Scotland. And I've been working in the industry for about 2 years now, and across a various range of technologies, platforms. I've dabbled a little bit with SQL Server, with Azure, Fabric, and I found that across all of these pieces of work, analytics are what I'm finding the most passion in. And I'm seeing a lot of these concepts translated really well into the world of sports, which is why I want to deliver this session today. What we're going to cover today, we're going to talk about what is the current landscape of data analytics in sports. What are teams and athletes actually doing with the data that they're gathering to gain the edge? We're going to talk about how we can build similar analytical solutions. So we're going to get a little more into the technical detail later in this session, where we're going to talk about how we can build a solution to work with data that's came from sports. And finally, we're going to try and talk about some examples about how we can translate this information into our day-to-day business use cases, our client projects and solutions. But during this session, I want you to keep some certain objectives in mind. I must plug my laptop in. Light interjection. All good, all good. Sorry about that. Can you see me? Can everyone still see me? Yeah? Are we good? What we're going to cover today in the session, we want to cover off some certain objectives. We want to talk about how we can actually deliver valuable data analytics. What needs to be considered when we're talking about these concepts to clients, to customers, and in our companies. We want to think about building data cultures. This is what the whole industry is moving towards, where we're looking at single pieces of data that can be used for analytics across a centralized experience. This is the whole motive of things like Fabric. And as eventually, we want to talk about the shiny things. We want to talk about our visualizations, our data storytelling. And I feel that these three concepts on the screen here are translated beautifully by some sports teams, people that do the analysis in their own time, people that are just obsessed with sports and the data that comes from sports and what they're doing with that, which we'll cover a few examples of. To deliver valuable data analytics, a lot of the concepts of big data surround these 5 V's of big data. We want to talk about the variety of data that's coming in. So are we getting telemetry data? Are we getting sensor data? What's actually capturing this data? Where is it coming from? We want to talk about the veracity of data. What are we actually looking to do with this data? What are we delivering with it? What value does it have? What value does it have to the customers? We're going to talk about the volume of data because we're in an age right now, we're in the era of data mounting up to the petabytes, the zettabytes of amounts, and we want to have solutions that are capable of keeping up with this large amount of data. We want to talk about the velocity of data. How quickly do we want to translate these insights into real pieces of analysis? And most importantly, in my opinion, the value of data, because without this data, without proper analysis done for it, it's worth nothing to anybody. And I would be remiss if I didn't talk about the Euro 2024 tournament, which is going on in Germany right now, because we've got Wimbledon on as well at this point in time, but there's some more interesting facts coming out from the Euro. For example, Tony in the room here is unfortunately a Dutch fan, and we are in England right now, so he is trying to hide from everybody, which is why he's in the room with me while I present. But there's some very interesting stats that come from football, and I've seen a lot of discourse around at what point are you trying to use data too much? At what point should you just be a purist and enjoy the game as it is? And there's a lot of that that's came out of this tournament. In the semi-finals, you can see that the top 4 teams, Spain, England, Netherlands, and France, that were in the semi-finals for the Euros, also happened to be the joint winners of the Eurovision Song Contest in 1969. It's a fun fact, but what does that mean for their football performance? Am I able to say that that's what the reason from the song contest in 1969 they were able to make it to the semi-finals? That's obviously not the case. And that is a case where we've not got correlation and causation actually occurring. We like to talk about expected goals in football a lot. And this is a concept where essentially how likely is it that a goal was going to reach the net? How close was the player to the goal? What angle was the football coming in from? There's all sorts of machine learning models that are in place now where outfits like Opta and StatsBomb can really put together all the data from a football match straight away during the match. They can calculate how much XG was generated from a shot at the goal. And there was a stat that came out that said essentially in the quarterfinals, before teams progressed to the semi-finals, every team that was knocked out actually generated a higher XG. And at this point, you have to think, is it because the teams that got knocked out, they were trying to score more goals? Were they closer to the goal? Or are we seeing here that the 4 teams that got through did they just get lucky? And at this point, there's a lot of division on the topic of XG in sports and in football right now, because a lot of people think it doesn't actually deliver any meaningful value. All it's telling me is how likely something was to happen, but how can we build upon that and move forward? So what I want to cover, and one more example of the XG here, you can see here, this is a shot map of when Manchester United and Liverpool played each other in the Premier League last year. Manchester United in the red, and on the right-hand side of the screen, Liverpool, all of their shots that went into the goal, and they managed to score one of them, which happened to be the closest to the goal. But you can see that Liverpool having a better XG there means nothing for them, because the Manchester United player decided to just take one kick of the ball from the halfway line, and it ended up in the goal. And at this point in the game, they were still 1-1 and tied. So there's nothing to say that a higher XG means that a team is playing more effectively. It just means they've created more chances. We like to talk about analysing players. It's a team sport, football, but there's a lot of individual talent involved in the game as well here. You can see on the screen, as of 2012, 2013, this is Messi and his conversion rates, his dribble rates, compared to an average football player. Maybe someone like myself or anybody else that would be playing football casually on the weekends. And you can see that Messi is just a much more complete and a much more talented player. But at this point, what are we trying to actually analyse about his talent there? There's a lot of stats that we can look into to try and decide if a player is effective on the pitch or not. This is a player called James Milner, played for Liverpool Football Club up until 2023. And won all sorts of trophies with them, including the Premier League and the Champions League. And what I'm going to show you on the screen here is a visualization of something. And you look at this and you go, Tony had a reaction to this where he took a step back and thought, all I'm seeing on my screen are big red blobs, right? Blot. It's just a big blot. It's a big, yeah, make of it what you will. This is every single time James Milner has touched a football on the football pitch over the span of 6 or 7 years playing for Liverpool in all competitions. And you look at this and you go, wow, okay, he touched the ball in a lot of different places around the pitch. What we can actually focus on here is the fact that he had 18,911 touches of a football during those competitions. Now, that still means nothing. Because I can say that number to you, you can think it's impressive because it's a high number, but what does that tell me about him as a player? How many chances is he creating? How is he playing with the rest of the team? It's not until we introduce another metric, which will come up on the screen to the right, which is minutes of football played by Liverpool football players. And if we focus on James Milner's stat there, you might have already noticed that he's played 18,899 minutes of football for Liverpool. So straight away, compared to me telling you that he's played 18,000 minutes or he has 18,000 touches, if I said to you that James Milner has touched the football during a game every single minute he's played for Liverpool on average, that in itself becomes a lot more impressive. That is a stat that actually has value to me because it says to me that James Milner is a player that will go for the ball at every single minute of the game. And suddenly this whole blot of a mess of a visualization on screen actually starts to make sense once you know the data that sits behind it. And I found a lot of value in this from a data visualization perspective, where it's not just about visualizing the one metric. You need to have enough supporting data around it to actually have it make sense to the normal viewer. The man on screen right now is a man called Johan Cruyff. And again, I have a nod of approval for the Dutch in the group. And this is a man that is often considered as the godfather of modern football. And he was active during the sort of 1970s, 1980s as a player and then a manager of the Netherlands national team and also Barcelona. And he's often regarded as a sort of pioneer of this concept of the Moneyball concept, in my opinion, because back then when he was asked about playing against a team like Real Madrid, which is a much larger team with a lot more resources, all he had to say about that was, I've never seen a bag of money score a goal. And it's true, because it's about the individual players and what they're capable of, and using that data analysis and those techniques and identifying those patterns that really brought Cruyff a lot of success in his managerial career. And it's one of the most common examples any of the Ted Lasso fans watching might know of total football, which is a concept of constant movement of players and using these triangles and these shapes on the pitch to be able to engage in this direct passing between each player and move the ball very quickly from one end of the pitch to the other. And this is something that's been quite heavily adopted by the Barcelona football team, and a lot of Spanish football is about this constant movement, this constant passing, and what they refer to as the tiki-taka. And we see a lot of those concepts with how different countries play football. German football is very much technical. It's a lot about the precise passes and the precise shots at the goal. Italian football is very passionate. You see the defenders properly run at the ball. These big guys, long flowing hair. They look like gods on earth playing football. Brazilian football, there's a lot of flair in how they play. They're known for their really quick dribbling and technique over the ball. And a lot of this you start to realize when you look further, you dig a little deeper into the data behind the game. And it starts to give you a little more appreciation for what is actually happening out there on the pitch and what the managers are responsible for. And you can see right in the middle of this chart here is a player called Josep Guardiola, commonly known as Pep, who is the current manager of Manchester City football team, who are the reigning champions of the Premier League in the UK. And he's brought a lot of these concepts into the way he manages that team. And again, there's almost a distaste for the way he plays football because it's technical, there's a lot of statistics that go into it. But to watch the game itself, sometimes people just enjoy watching a little more fluid motion of football, something that's not as scripted and heavily created in terms of these tactics by a man called Pep. And we're seeing a lot of that coming from the Euro tournament as well, with some teams coming in and just completely demolishing these tactics because they're playing in a way that just isn't expected at all. But a sport that does really rely on that data, I've talked about how there's a debate in football about the place of data and do we really need to get into the deeps of that data? But a sport like Formula One relies so much upon the data that it's come leaps and bounds in the past few decades to the point where it's one of the most technologically and mechanically, from a mechanical engineering perspective, is one of the most advanced sports in the world. The amount of engineering that goes into building these cars, the amount of money and development that goes in, is absolutely staggering. And a lot of the concepts of Formula One engineering do actually make their way to our road cars. So in the 90s, F1 cars were already using traction control, ABS, things that you'll find in your road car today. And they're now pioneering a lot of the innovation in the engine space and using these biofuels as we move to a greener future with our road cars again. And a lot of Formula One is about analyzing the data and trying to chase margins not of a second or 0.1 of a second. I've seen margins in Formula One that come really close to the point of 3-4 decimal places of a second. And at that point, there's just a thin margin between each of the drivers. So any split second on the track is a massive gain for a Formula One team. The current pit stop world record is held by the McLaren Formula One team at the Qatar Grand Prix last year, and it's currently 1.8 seconds to complete a pit stop. I've got the recording on screen here. And there are some other angles that you can see of this on the screen. So this is roughly 14 and 15 people working in perfect unison to take off the 4 tires and put on 4 new tires, and 2 people at the front and the back of the car to lift it because it weighs roughly about 500 kilos, I believe. And that's all of those people working in perfect unison to be able to get a car into the pits and out in 1.8 seconds. We were trying to find where the dinner for the speakers was in Cambridge last night, and there was maybe about 7 to 10 people there. And it took us longer than 1.8 seconds to actually, as a group, achieve something and do something successfully. That is a group of 15 people doing something so perfectly that they've all done it in that smaller margin. And that will make a massive difference for that team. If there was another car up the road that he was half a second behind, and that car has a pit stop that's slower by half a second, that's an overtake for this team. And that is how close the margins are in Formula One. And that is why they rely so heavily upon the data and the timing that they can gather from the cars. This is a screenshot of Formula One from the 80s. The sort of 70s and 80s was often regarded as the sort of golden era of Formula One for advertising. And, you know, it's a sport that looked really attractive. You had all these cigarette and alcohol sponsorships. Yeah, brands like Marlboro and Camel are synonymous almost with some teams and their identities from that time. Obviously, with advertising laws in the current age, all for good reason, we don't see as much of those sponsorships. But what we do see more of these days is data partnerships. Companies like Splunk and Alteryx, Darktrace, Dell, Microsoft are all teaming up with these Formula One teams to deliver them efficient data analytics. And the teams see a lot more value in that now compared to partnering up with someone like a drinks brand or a tobacco brand. And that is because data is now the forefront of the sport. It's no longer about the sponsorships or the drivers or the cars. It's everyone cares about the data and how they can use it. And AWS is the major partner for Formula One, and that's what they run all of their telemetry, their machine learning models upon. And every single weekend at the F1 racetrack, you've got the team sitting by the side of the track looking at these screens, which are feeding them real-time telemetry from a race at any point. What is happening with the car? Where is the car? They've got multiple sensors on the cars to give them all the information that they would need with a Formula One car as it goes around the track. And they've also got teams back at the factory doing even more processing of the data that's coming from the car to be able to deliver those decisions that they need to make in real time, those split-second calls, whether they should pit, whether they should hang back a bit and try and manage their car. If there's overheating in the engine, for example, there's a certain amount of things that the driver needs to do to control that situation. And this is just an example of some of the things that can be sent, that can be brought in from an F1 car. These are just a few of the sensors, such as the engine speed, what are the RPMs, how much is the temperature of the engine, the tires, the car itself, how much G-force is the car pulling as it goes through a turn, what's the steering angle. All of these sort of things are tracked by an F1 car. And a usual F1 weekend consists of about 2 hours of racing on the Friday, 2 hours of practice on the Friday, an hour of practice on the Saturday, continued by an hour of qualifying where they try and set the grid for the Sunday, who can go fastest, who starts where on the Sunday, where they race. Over 300 kilometers, it happens to be around 2 hours, 2 to 3 hours for a race. And during every single one of these sessions, teams are receiving data from the car, and specifically 300 sensors from each Formula One car are delivering over 1.1 million data points every single second that an F1 car is on track. Every single second, they've got 1.1 million data points. And that's over the span of the 2 hours on Friday, the 2 hours on the Saturday, and the 2 hours on the Sunday. Each team has 2 cars. If anyone wants to do the quick maths on that to tell me how many data points are being captured over the span of a weekend, we'll come back to you at the end of the session. But it's a pretty large number. And it's up for debate, so I didn't quite want to put a figure on screen and then have someone go, actually, it's this, actually, it's that. But no matter whatever the actual figure is, you can agree that it's quite impressive that a team has to make sense of 1.1 million data points that are coming in from that real-time telemetry and actually make sense of it to make those decisions. And the way they do this is through these telemetry graphs, which are recording those key metrics. So you'll see in the bottom left there, the 4 ovals are the tires. How much wear is from the tires? How much grip do they have left in them? You can see the line charts are mostly the throttle and the brake input and the G-forces. So at what point is a driver using more throttle than he should, or using where should he brake more than usual? A lot of the time, the engineers that I showed you on the pit wall, what they're doing is they're in the ear of the driver through the radio saying, maybe you should use a little more throttle going into this corner. Maybe you should brake there. Maybe you should follow the other guy for a little bit of a slipstream. And you can imagine how a Formula One driver going at 300 kilometers per hour, going down the straight of a racetrack with all this noise around him, all this car he's got in his hands, it's his life in his hands, because if he does one wrong turn, he's off the track into a really bad crash. And all of that's going on, and they're still able to focus on the messages from the team on the radio. The example I like to use for this is imagine yourself, you're trying to drive down a street and trying to find an address. What do? We usually turn the music down because it's a little too loud so that we can focus better on where we're trying to go and follow the sat nav. Try being a Formula One driver with all that information getting thrown at you every single second, and you've got to make the decision to brake 50 meters later when you're going at a speed of 200 miles per hour, which is why it's a very exclusive sport because of how expensive it is to put these cars on the track. And there's a lot of debate around that as well. But there's a reason there's only 20 drivers in the world that get to do this as a job, is because they have to have that level of talent and dedication to be able to deliver those results week in, week out. So what we've done there for the last roughly half an hour, we've discussed all these concepts of data analytics, how the sports teams are really putting them into practice. But we've not really looked at anything technical. We've not tried to understand how we can start to make sense of this data ourselves, which brings me to the technical part of this presentation. So you've already met me. I'm Abby, the data engineer, as you can see on screen there. But there's another Abby to meet, and he is Abby, the F1 driver / F1 engineer / F1 manager. Shout out to Darren Phillips, Quorum's marketing manager, for whipping up a photo that's definitely not photoshopped, but he's just done a little bit of adjustment to it to just make me look a bit more ready for the F1 racing for Quorum Formula One team. And what Abby says is, I was at a race in Italy at the track called Monza last week, and I have all this data from my car. I want to analyze it. What can I do with this data that's came from my car? He says to Abby, the data engineer. And we go, okay, let's have a look at the data. And obviously, Abby, the F1 driver, doesn't know any better. So he's got all of his data stored in Excel, which obviously, as data consultants, we love. We love it when people come to us with all their data in Excel, right, Tony? Sometimes good, sometimes bad. But what we have to do now is we have to try and make sense of this file of just rows of data, that telemetry that doesn't right now mean anything to us. And we're trying to put it into the context of what Abby was trying to do on the F1 track last week. And he does have a quick replay to show us from the start of that race. So you can see here in the orange car, getting ready for the lights to go out, starting in the 6th position, lights out, away they go, gets a fantastic start, already past the blue car on the left, already making massive gains on the cars in front, thread the needle, dart to the left, go for the overtake, breaking down to the first corner, tries to make it stick, tries to make it stick, tries to make it stick, managing the inputs there, but you can see that he's not able to overtake that car out of that corner. So straight away, Abby's saying to me here, what could I have done better going through that first corner? What are other cars doing in that? What are their throttle and brake inputs like? And that's obviously a real clip from a real Formula One race. It's not a video game where I've turned down the difficulty of other drivers to look better. That would definitely never happen in a presentation of mine. But Abby's asking those questions. He's saying, what can we do with this data to actually make it make sense? And what Abby, the data consultant, whose daily job is to educate people on the wonders of the platforms that we get to work with day to day, Abby says, let's use Microsoft Fabric to use this data, specifically the real-time analytics experience of Fabric, which is now rebranded to real-time intelligence, because there's a lot more in terms of features that we can use with it. And it's something that's evolving day to day because Fabric is being developed so heavily right now. What we're going to do is we're going to jump over to a quick demo. Any questions so far that aren't related to my favorite F1 teams or football teams or whatever? Doesn't look like there's anything so far. Oh, good. Anthony says 24 billion data points. So yeah, I'll take those. I will come back to the comments at some point or another. But what we're going to do is we're going to try and build a solution in Fabric for Abby. And there was one slide that I forgot to show you all, which is quite important. And it's our shopping list for Fabric, what we're trying to build. So we're starting off with our CSV that Abby's got in Excel. And what he's going to try and do with that, we're going to try and bring it, into a lakehouse in Fabric where we can store our files. We can upload files of any format and they'll be stored in the Delta format for use by the rest of the platform. What we're going to do, we're going to ingest that lakehouse, the data in that lakehouse into our Custo database using a notebook. And then we need to present that data in various experiences on the platform. And you can see this is how we're going to flow the data there. So we'll jump over to Fabric for our demo now. And you can see here that we've got our lakehouse with our CSV of data that Abby has given us from the Monza Grand Prix last week, sorry. And all this is just the file itself sitting in a lakehouse that I've got in my Fabric workspace called Stream Telemetry. And what I'm going to do here is I'm going to use a notebook with some Python scripts to stream this data from this lakehouse into a Custo database. But before I do that, I'm going to set up an environment which you can do in Fabric now, where you're able to build all these sort of custom libraries that you want to be using with a notebook. What you can do is in Notebook itself, you can import the libraries from sort of your open source format of choice, any of the Python libraries that you do want to use. But what you can also do in Fabric is build what is called an environment. So this little logo there is where you can pull in all these sort of public libraries. And for ease, for a little more streamlined demo today, I've already pulled in the Azure Event Hub library, which is what we'll need to use in our notebook to be able to stream the data from that CSV. So if we go over to our notebook, what I'm going to do is I'm going to give this a little kickstart of my session, and I can talk you through the code to make sure that we are all good to go when we click the green button. So you can see here, we've just got a couple parameters that we need to set. One being my connection string for what we're going to use in the event stream, which is what's going to actually do the processing of the events from the CSV to the lakehouse, to the database, sorry. And we also need the endpoint for where the CSV file is actually sitting so that we can connect to it. And what we're going to do is we're going to set a batch size for our rows. So I want to, not to overload the event stream, I want to just pull through 100 rows from my CSV each time. And you can see here that I've got the line of code to install the Event Hub library, but we don't need this because I'm already in my streams environment here. If I was in a different environment that didn't have that library, I would have to pull that in again before I run it. And all of this code is available on the Microsoft Learn documentation for using CSVs to pull this data into a KQL database, which I will link in a GitHub link to be sent out to all the attendees later today. And all we're going to do in this code is grab some dependencies. So some of the dependencies from that library that I mentioned earlier. And then this is our streaming cell. This is where the magic happens. So what we need to do, first of all, plain and simple, read the data from that CSV and have it in a Spark data frame that's ready to be ingested and streamed. We can set some control variables here just for the actual batch itself and just have some information given to us while we're doing the streaming of what's our target, how many batches are we dealing with, how much data is actually going to end up streaming through. And then we want to loop it where we've just got our batch counting up, and it will send the batch to the Event Hub, which is then going to take the payload, chuck it over to our destination of choice, and then continue. So what we're going to do here is we're just going to go ahead and start running the notebook and start streaming our data. But we do need to decide pretty quickly before the data piles up of where it's going to go. So what we're going to do is we're going to jump over to our event stream. And for those of you that haven't seen one before, this is an event stream in Fabric. And all this is a no-code way of choosing a source, which can be from Azure Event Hubs that you've already resourced, or just some sample data if you're wanting to see what an event stream can do. What we've done here is we've used the custom app source because I've got a Python notebook, and all I had to do was just use the endpoint from this custom app for my notebook to connect it, which is involved in the tutorial there as well. And I've done this for ease just so that we can go through things a bit quicker. But what we need to do here is we need to set a destination for our data. So we can send it right to the lakehouse. We can send it to Data Activator if we want to do some real-time processing of some actions and triggers. But what I'm going to choose to do is I'm going to send it to my KQL database. And you can see we've got a couple options here already. So you can see that we can do direct ingestion if we wanted to, or we can start processing some events before they actually reach my KQL database, which is why you can see that once this is set, you can't change it with an event stream, because you can't obviously start changing data once it's already been streaming. I'm pretty happy with the format my data is in already from the CSV. I did some checks, but we will do some checks again when we're doing the ingestion. So I'm going to go ahead and just pick direct ingestion here. We've got to give our destination a name. So obviously it's going to be stream to the KQL DB. And I've got to choose my Fabric workspace with my Fabric database, KQL database that I'm going to send this data into, which is my streamed telemetry database. So I can add and configure this destination, which I will do now. And what hopefully will happen is it will realize that I've got my destination set up with this database, but it's going to ask me, what table do you actually want this to be sent into? Again, for ease in the demo, just to run things a little smoother, because I know how temperamental these things can be sometimes, I've already got a blank table in my database where I've done some of the DDL commands that you would need to, such as setting the schema of all my data types. I know that everything's going to match one-to-one, but I can show you pretty soon how we're going to map that over. And you can see here that we've already got our table there. And what we're going to do is we're just going to make it sure that it's got a unique connection name that we can use. So from our event stream for data left unattended. If I go to next here, you can see that hopefully if the notebook was working, fingers crossed, we do have some data coming through from the notebook right now. This is a sample of 50 events. We can look at some more data if we want a bigger sample, but I'm pretty happy that I can tell that the data is all okay looking at these 50 events. And I'm going to take a quick scroll through because I sometimes know that some of these columns are not going to show up. And I've been able to recreate this each time where for some reason in my source CSV, there is an issue with the break column. It's not maybe mapped correctly for the streaming. But what we can do here is we can edit all the columns that we are mapping to. And this is where you would do any transformations for your columns as well. You can choose to just not bring the column in if you don't want to. But obviously I have a CSV that's linked to the table in my KQL database. So I want to make sure that I'm bringing all the columns in at the same time. And you can see here, for some unknown reason, if any of the Microsoft MVPs who are pretty close with the Custo team could tell me why this has happened every single time I've ran this demo, I do need to just make sure that the break column from the source maps to my break column in the destination. And hopefully if I apply this and we go back to the mapping preview, you can see there that I've got the telemetry for the break. So I'm pretty happy that all my data is going to be ingested into the KQL database as I need it. So I'm just going to go ahead and hit finish here. Let's just try and create a new connection very quickly. But if not, we have some other data that we can use. We're going to use our destination table here, as we had. We're going to have it here. Data coming from the stream. And we're going to map those columns again for some reason. And you can see all the telemetry that's coming from the CSV there. But we only care about a few of these. And we'll make sure that we bring the steering in just in case we need it. Apply that, finish that. We've got an issue again for some reason. Okie dokie. What we're going to do is we're going to just go over to our KQL database. If we've got some data in there already, hopefully, I can show you some examples just off of that. But what we'll do for now, actually, just to keep things safe, I tried to show you how the event stream works, but obviously Fabric's not our friend today. So what I'm going to do is I do have the raw CSV in my files. So I'm just going to upload that, and we're just going to use a one-time batch load for the demo today. And hopefully this shouldn't take too long. And we can see here the mapping experience of when you do a one-time batch load is pretty similar in real-time analytics for a Kusto database. And you can choose all the different sources that you've got there as well. But we can see here that all of our data is there as we would need it. So we're going to go ahead and just take this data and ingest the whole lot. So unfortunately, we're not going to be able to simulate the stream of our data, but we do still have our data there to do some analysis on for Abby, the F1 driver. And this should only take a few seconds. And we've successfully ingested all 75,000 rows, roughly, of our telemetry data. And what we're going to go ahead and do is we're going to go and open up this data, and we can query it using any of the records here. But what I've already done in my workspace is I have a Kusto query set, which is essentially your query file of queries that you would run against a Kusto table. So we're not going to run any of the ingestion commands because we weren't able to do a successful ingestion. But what we can do is we can start to run queries to understand what the schema of our data is. So you can see all the columns there. You can see everything that we brought in with the column types that we would look for. And you can see here that I've got 75,000 rows. And I'm not going to go into too much detail of the KQL syntax today because there's a lot of resources out there. There's a lot of people smarter than me that know a lot more about Kusto that can tell you a little more detail. But I will, as I said, gather all the resources and put them into that GitHub and share it at the end of the presentation. So in Kusto, what you want to do is usually give your table name, and then it's a pipe operator, and then at that point you can do any of your functions or projections that you want to do. So in SQL, usually where you write a query, select column from table, what Kusto actually does is takes the execution order where you're able to go table, what you're wanting to filter, what you're wanting to aggregate on, and then at the very end of the query, we're going to actually pick the columns that we need. And it's a little more intuitive to work with to do some exploratory data analysis of this data. Because you can see here, even if I just highlight the table name, I'm going to get all the records from the table. Which is maybe not a wise thing to do because we've got 75,000 rows and Fabric is not happy. So it'll be a little nicer, and we'll only take the 10 rows there. Maybe my trial is almost running up and I'm running out of resources in my Fabric. So you can see here we've got a sample 10 records from the data, and we can see all of our telemetry as it was in the CSV. I'm going to start doing a little bit more analysis of this. So what I'm going to do is I'm going to just give us a quick line chart of my throttle input, but I want to just filter this down just so that I don't overload the query engine again. So what I'm going to do is take anything from the lap number of 5. And we can see here that we've got the input here of my throttle input as it would have been over the span of lap 5 from that F1 race. And you can see here that essentially wherever the throttle value is 1, that means full throttle. Wherever it's 0, the foot is off the throttle. And these individual spikes are where we want to put gradual pressure on the throttle so that the car doesn't spin out while racing. And we're going to do a similar thing for braking. If I run these two queries together, you should see pretty quickly that there is a pattern of whenever the throttle is applied. So, okay, maybe we can't do both at the same time. But what we'll do is we'll apply the throttle there. If we have the brake there, you can see that it spikes at similar points, but the brake is actually at 1 wherever the throttle was 0 and vice versa. And they've got to do some analysis there. And there's two different ways we can visualize this data in Fabric at the moment with real-time intelligence. So if we've got the data ingesting as we would want it to, what we can do here actually with our line chart is we can pin this query, this visualization that I've actually ran, to a real-time dashboard by highlighting that query and clicking that button. And what I want to do is I want to take a new dashboard. I want to just populate this with all the data that I had maybe from lap 5. So I'm going to say lap 5 telemetry. And this tile is going to be my throttle. And we want to see what the dashboard looks like once we create it. But this means that within Fabric, I'm able to create a dashboard where I can look at my data as it's being ingested, as and when. I can set a refresh of what I want to do with the data as well by managing it. But obviously, we're not ingesting anything right now, so we don't need to actually refresh anything. But we can see here that we've got this tile. And if we were to go back to the query set and do the same with the break chart, put it to a dashboard, but this time I've got my existing dashboards, and this is break. You can see how easy it is to actually start pinning all the visuals that you want onto this dashboard, and you can start to see how they line up there, and it starts to give you the refresh information there. And what we can do is we can edit this, add in our axes, labels, any of the legends. We can do some nice things for our customers to look at the data as it should be in a nice, neat format. The other option that you do have in a Kusto query set is to send that data directly to Power BI as well and start to build an actual report where you've got a semantic model. So something like a real-time dashboard is much more useful for when you've got data that's being constantly ingested. But you can take a query that you've got of all these values, and what you can do is highlight the query, click the Power BI button here, and what you get is Power BI itself in a little preview window while you're running your Kusto queries. And what you're able to do here is we can start to build the same visualizations. So very quickly, if I say I want my throttle input over the lap distance, X and Y axis, bish, bash, bosh, and you can see this is obviously over the whole span of the race. So we want to add a legend of lap number as well. And you can start to see that we've got all the telemetry from every single lap here. So obviously, in good practice, we would add a slicer to this so that we can filter to each lap. And this looks a lot more similar to that telemetry dashboard that I showed you earlier on. And you can see that a lot of the inputs are quite consistent across the span of the race. So what difference did this actually make for Abby, the F1 driver? What did putting all this information into Fabric do, where we've got this dashboard that we can look at? Did it actually help him in the race at all? And I can very easily answer that question for you by going back to our PowerPoint and looking at one of the race replays. You can see there that we've got our Excel. We took our file from the lakehouse. We used our notebook to attempt to stream the data into our KQL database. And you can see here the icon at the top. We've got our query set that we were using to interactively run some queries. We've got the icon in the middle is our real-time dashboard that we created where we were pinning the visuals to the dashboard itself. Or we can send that data to Power BI, our Kusto query result, and actually start to model it and work with it better. If we take a replay of the same race, but now we're on lap 12, and you can see the orange car there, diving down the inside of the Red Bull car there. And you got a fantastic slow motion shot of this. This wasn't planned at all. You can see the same corner where he failed to make that overtake the last time. He was able to understand that he just has to brake a little later into that corner. Should put a little more throttle and he's able to stick that overtake. And you can see there, the checkered flag is waving, and the orange car that Abby is driving has won the race. Yippee. And you can see there that compared to all the other cars, he was using that data a little better. He was using that data that was in our Fabric dashboard, reviewing it with the engineers. His engineers may be on the radio saying, you should have done this there. And he's able to react to that in real time and make that decision. And that is all I have from my presentation today in terms of what I'm sharing. So as I said, for the first half, we talked about analytics examples from sports teams. What are they actually doing with the data? How are they visualizing it? How are they showing it in a way that actually makes sense to the viewers? And then we were able to use Fabric, or attempt to use Fabric, to have a solution that we've got in place to pretty quickly still stream that data in and analyze it on the fly. considering in the span of about 15 to 20 minutes, we had a solution up and running with the notebook and or even the batch load. It's not as much work as it maybe would have been with something that was like a PaaS service, like an Azure Event Hub in the Azure portal. This is what things like Fabric are doing to help simplify the experience of delivering these analytics by having all of that organizational admin and the overheads taken care of in the background as a SaaS product. And you can see that we've used a little bit of all the experiences across the platform there. But the key thing is we've only used one single copy of the data.